Welcome to Lecture Online. Our next section in electrical engineering is about basic laws of engineering and basic laws of electricity and magnetism. We're going to start with talking about resistance and resistivity. What is resistance? Resistance is the property of a material that resists the flow of current or resists the flow of electrical charges in a circuit. Let's say we have a circuit here, carries a certain amount of current, comes upon an object that has resistance. The resistance will limit the amount of current that can flow through the object. The amount of current that can flow through the object is proportional to 1 over the resistance. If you double the resistance, you will have the current, triple the resistance, you have 1/3 the current, and so forth. The units for resistance is ohms. Resistivity is the property that an object has that gives it the ability to have resistance. The greater the resistivity, the more resistance the object will have. The equation to calculate the resistance of an object is equal to the resistivity of the object times the length divided by the cross-sectional area. If you make the cross-sectional area bigger, there's more paths for the current to take, and therefore it will lower the resistance. If you make the cross-sectional area smaller, there's fewer paths that the current can take, and therefore the resistance increases. If you make the object longer, there's a longer path through which the current has to struggle through the object that has resistance or resistivity, and therefore the resistance will go up. So again, the equation is the resistance of an object is equal to the resistivity times the length divided by the cross-sectional area of the object. To get some feel for it, first of all, let's talk about this is the symbol for resistivity, and the units are ohms times meters. The reason why we need it to be ohms times meters, because length is meters to the first power, area is meters to the second power. We have to negate the concept of meters to get resistance, which is simply in ohms. So ohms times meters will negate the meters squared divided by meters squared. To get a feel of the type of resistances we have or the type of resistivities we have in different materials, notice silver has a very low resistivity, meaning it allows the current flow to be very high. So is copper. So copper and silver are primary substances that allow current to flow. Since silver is too expensive to make electrical wiring from, we tend to use copper. Aluminum, being much more abundant and much cheaper, is also a substance being looked at to use electrical wiring, but notice the increase in resistivity, therefore much more energy loss across the wires. The wires can get hotter, and we'll talk about that later when we talk about the power dissipation of wiring, but you can see that copper is by far the primary substance that people want to use. Aluminum is not very kind of looked at by insurance companies when they want to insure homes and buildings if they have aluminum wiring because of the increased resistivity. In comparison to metals, you can see that carbon and germanium have much higher resistivities. These fall in the category of semiconductors. You can see that they're much more opposed to the flow of current as metals do. That gives us a good basis of understanding. Notice resistivity is the property that gives objects their resistance. Resistance is what gives opposition to current flow in circuits. Therefore, current is inversely proportional to the resistance. Increase the resistance, you will diminish the current proportionally. And that's the start of this new section on electrical engineering.